You've heard from Microsoft. We wanted you to have a chance to hear from Qualcomm and what they're doing, because Qualcomm's come forward and they've helped animate this space of end user compute, right? As customers, we've never had more choices than we have now. So it's a really exciting time, but it also, you got to make the right decision. So we've got Craig Talalian here from Qualcomm to help us learn more about that. So Craig, I just wanted to start out with, tell us a little bit about yourself.
Yeah.
So how'd you end up on this stage?
So New York, New Jersey, born and raised, but been in the tech sector for almost 30 years now. Always have lived on the East Coast, but worked for West Coast companies. So I've had 10 years at Sun Microsystems, spent some time at Palm during the BlackBerry iPhone days when we ran Windows Mobile, as well as Palm OS. And then before coming to Qualcomm 3 years ago, I was at Microsoft for 13 plus years, where I spent a lot of that time supporting the mobile compute space on Windows Mobile, and then pivoted over to Surface, where I ran a lot of the Surface commercial strategy for the field sales team. So yeah, it's been a great journey and real exciting right now to be at Qualcomm as part of this new revolutionary opportunity around next generation compute and AI.
So wait a minute, you grew up in New Jersey and you worked for Qualcomm in San Diego. I grew up on the West Coast and I work for SHI here. We should talk. We got to sort this out.
Yeah, you can't find good Italian food on the West Coast,
That's
though,
true.
so you got to stay here. So.
Well, tell us a little bit about, it's interesting that you kind of came up from the mobile side, which is a similar story with Qualcomm, right? We all know Qualcomm on mobile, the ARM processors that are powering so many of our devices. But talk a little bit about, Qualcomm's sort of migration from mobile into the PC space.
Yeah, so Qualcomm, we just celebrated our 40th year anniversary. It stands for Quality Communications. So if you've ever had back in the day a smartphone with CDMA technology, that was powered by our Qualcomm IP. So we really evolved from being purely focused on cellular wireless networking to really becoming this fabulous semiconductor in designing the chips that power IoT, that power mobile handsets like Android devices, as well as automotive and compute is another area of focus for us. And we really have this vision and strategy where there's a lot of processing that can occur at the edge, but also doing it in a much more power efficient way. Because when you come from the handset space, you don't have the luxury of being connected to a wall throughout the day. You need that device to be functional and high performing on battery and get you through a full day or multiple day.
That's good. Yeah, I mean, it is amazing how these things have migrated and merged. And so, the Snapdragon devices were announced last June. They really hit the market strong in September. And, I guess in your world, what would differentiate a Snapdragon device from the x86 devices that are already in market?
Yeah, so if folks are familiar, there's the traditional Windows operating system, which is x86 architecture. And if you think about that architecture, it was designed and built traditionally to be connected to a wall, right? It was started as desktops, and then as PC compute evolved, people became more accustomed to carrying a laptop or carrying a tablet. And we're leveraging a different architecture. It's Windows on ARM is the architecture, which is a reduced instruction set. And the benefit to that is you're able to turn up these compute engines at a much lower power level. So we're able to really stretch the life of that device. And when you care about battery life and getting through multi-day, that's where our technology, we really think, shines. And so we've done a lot over the years working with Microsoft to optimize the Windows on ARM OS experience, while also ensuring that we're delivering great performance per watt. And yeah, it's been an exciting 6 months since we started to see all of the OEMs, Dell, HP, Lenovo, Surface, Asus, Samsung, Acer, all start to enhance their portfolio with Snapdragon-based devices.
That's great. It's like I said before, it's great to see another player in that space. The amount of options customers have, the choices it's just never been better, right, from that perspective. But there is sort of the other side of that coin with ARM and with RISC-type processors, and I think a lot of people are familiar. Rob McGilvery talked about it a little, from Microsoft talked about it a little last night, about application compatibility. And I know you guys have done a bunch of work. We were talking earlier. As a matter of fact, there's a gentleman in the audience here who he and I worked on an early Surface X device, right? That first release, and it was like, we weren't quite there yet. But a lot has happened since then in terms of application compatibility. So what's your view on where we are and where we can go? And that's always going to be a concern for everyone here. If I buy this device, is it going to work for my users? How do they tackle that? What can we do to help them? So kind of walk us through that.
Yeah, and if we kind of take a step back in time, it was over a decade ago that Microsoft launched the first Windows RT device. And for folks that are familiar with that, it ran Windows on ARM operating system that only supported native 32-bit applications. So it was pretty much a great concept, but from an operating perspective, it was pretty dead in the water. And Microsoft kind of started to iterate on that. And when they introduced Windows 10 for ARM, they allowed for emulation support for 32-bit applications that were x86 compiled. That was good, but most of the people were moving to 64-bit apps. So Windows 11 then came out on ARM, and it allowed for emulation of 64 and 32-bit applications, which was a great experience. But then with the latest version, Windows 11 24H2, which is also what Microsoft brands Copilot Plus PC, that now has an enhanced emulation layer called Prism. And we're able to achieve, on a multi-threaded performance, 90% of the native app experience, but running emulated. So the performance, if you have to run emulated, is significantly better than you ever probably had seen in the past. But I'll also tell you guys that through Microsoft telemetry, we know that anyone that's on a Snapdragon device today, over 90% of the applications that are running native. So the application ecosystem has really evolved to the point now where all of your top consumer apps and enterprise apps now have native ARM experiences to really make that hopefully be a non-issue for you as an enterprise.
So, that's great for the commercial apps, right? It works well. Those are well known. We've got a lot of customers here who have older companies. They've done a lot of their own development. They have what I term the applications that can drive, vote, and drink, right? They've been around a little while. Those are some of the more challenging ones. But how do you approach those? What resources are available, or how do you kind of assess and then figure out what your options are?
Yeah, so folks that may not be familiar with how the emulation layer works within Windows, so an application can run emulated on ARM as long as it's not making any kernel level calls, which in the enterprise, anything that's a security application is likely talking to the OS kernel. So we've done a lot of work with Microsoft and with all of these top ISVs to help ensure that they're able to offer native ARM drivers for all of those experiences, whether it's endpoint protection or data loss prevention or VPN or encryption. Those applications all have now ARM supported versions with native ARM drivers or fully native. So the discovery is part of where my team comes in. So we can offer guidance in helping identify what are those apps that you need to basically enable the ARM version. We also have partnered with folks like SHI to help with those services as well. I would say if anyone in the room has ever deployed a Mac environment, and if you're familiar with the transition from an Intel-based architecture to Mac OS going to an ARM-based one, then you're probably comfortable and understanding how that would work. But more importantly, you probably already see the benefits of an ARM architecture in terms of performance, battery life, and thermals.
That's great. And I appreciate you mentioning us as part of the services. And for those of you that had a chance to visit our next gen device lab yesterday, that's a place where we can help you with those application compatibility challenges. We can run workloads, help you understand what's you're able to move forward on, or what'll be the things that are going to take a little more effort. And that's part of, we always really appreciate our partnerships with all our partners, people like Qualcomm, and we want to build more of that for you guys to make it easier. So that's the application side. Let's get back to the hardware side. So Snapdragon, I think it's 45 tops, if I remember right.
Yep.
Everybody's got a different tops number. But when you think about that, what do you think about the specifics of that type of capability and how it sort of manifests itself in either productivity or security benefits for an employee, for our customers?
Yeah, so and a lot of this aligns with what Microsoft's trying to do in delivering sort of this next-gen PC experience, which, again, they branded Copilot Plus. And when you think about that version of the operating system, Windows 11 24H2 has native to it a number of these language models. that are core to the operating system. And those language models are basically able to handle things like background blur or live captions with transcription. These are all things that historically, for them to deliver them through the CPU or the GPU, would consume a lot more power and raise the thermal temperature. Microsoft's now engineered that to leverage an NPU. So the NPU, think of it as the AI engine, but it's able to run at like 1/20th the amount of power draw of a traditional CPU or GPU. So for us, it's really exciting because our silicon is able to deliver that same NPU performance, whether you are in a 12-core version of our silicon, a 10-core, or an 8-core. So we almost describe it as you're able to have democratized AI experiences, whether you're in a sub $1,000 PC or $1,500 or $2,000 PC. And those experiences are going to, we think, really increase the productivity for the end user. So, and we can talk about that, Dave. Like, we're seeing a lot of customers lean in to say, I want to understand how I can do more with AI, generative AI, but I don't have, the budget to keep spending money on the cloud to do that. And I'm also concerned about privacy and security. So running those models locally on device becomes a real thing now. And we're seeing a lot of customers pivot towards those chat GPT-like experiences, but running it off network on the NPU of say, a Snapdragon-based PC.
And I think that's what we're really excited about, this idea of hybrid workloads. And I kind of want to lean into that a little bit more. You work with a lot of customers. You worked with a very large customer that is looking, I know they're looking specifically at Snapdragon to do some of that hybrid work. So talk a little bit about that, and maybe let's get into a little bit about orchestration. I think you've got some other great examples around that.
Yeah, so and we're seeing a number of key vertical industries lean in, FSI in particular. It's right in our backyard, here in the New York, New Jersey area. And, they're trying to see how you can leverage AI, but locally, because there's concern about end users sending queries up to the cloud, and that again could compromise the privacy of that corporate data. They're also concerned about latency, having to go back and wait for that processing power. So one of these FSI customers has actually started to develop these RAG bot type of experiences. And if folks are familiar with the term RAG, it stands for Retrieval Augmented Generation. And think of it as when I have a chat GPT conversation today in the cloud, it goes up and it's referencing whatever that model is. And if it doesn't know the answer, it could hallucinate and give me something that isn't actual true. With a RAGBot concept, you're pointing it to only your own digital assets as a corporation. So I could be a wealth manager, and maybe I have a bunch of these PDF documents that are proprietary to what my analysts have developed. And so when I engage with that local RAGBot model, it's having a conversation just with those documents that are the single source of truth. And the beauty is all that is running on the NPU, so it's freeing up the CPU and GPU resources to do other things. So yeah, it's amazing to me the amount of innovation that's now going to happen in this space. I will also just comment that when you think of running these models locally, those models run in memory. So what is becoming a new paradigm shift is it's more about how much memory capacity you have on the PC, and less necessarily about how many cores you have in your CPU. So I'm seeing the new normal become 32 gig of memory, just because as you load these models in, they start to eat up the amount of memory capacity in the PC.
Well, and that you're doing great. You're touching all the things I want to get here, but you talk about like 32 gig memory. That gets lost. People get focused on the chipset, and you've got to run these things in memory. And the term that keeps coming up is future proof. But I kind of think we should change that term to future seed, because you're literally making decisions to seed for future capability. It's not a defensive move. It's an active move to enable your devices. And that's something we all need to think about, because these workloads are coming. Yeah. It's a reality, right? I mean, you see it every day. You were telling me about, in the hybrid space, about, if I remember right, it was about covering a whiteboard to extract data and then do analysis in the cloud. Can you walk through that a little bit?
Yeah,
That was really interesting.
Yeah, so if you are familiar with these different language models, they can be anywhere from 1 billion in size to 7 billion, 14 billion, upwards to the hundreds of billions. And if you think about like the processing that's occurring in these NVIDIA DGPU farms, we're talking 100 billion parameter models. They're doing a lot of the training. As more of that training is happening, the inferencing capability is able to be more effective in these smaller models. So like today on the edge, like we're looking at models that are below 30 billion parameters running locally on device. But then there are going to be use cases where the model needs to be larger. So this concept of orchestration in a hybrid AI world is becoming a reality. And we have partners like Deloitte that have stood up practices around this. That the one scenario that they demonstrated at Microsoft Ignite recently was two developers are in a conference room. They're basically whiteboarding the concept of developing this new code framework. And they whiteboard it, but at the same time, locally, the PC is capturing all of the meeting notes and transcribing. That's all happening locally on the edge on that PC's MPU. But then once it captures that whiteboard session, it then orchestrates to send that up to a larger model in the cloud, and then that's able to bring down and process the actual code for the end user. So this ability to take certain components and certain models can run locally on the PC, others end up going up to the cloud. I think that's going to become like the new normal for a lot of the way these workloads work.
And I think it seems to make a big difference too, right? If you can do that processing locally, you're unloading your data center, you're unloading a cloud provider. Have you seen cost modeling for that shows if I can move this workload locally, what I might save, or to make that balance of investment in either side of the infrastructure equation?
No, absolutely. And like there's been a lot of news in the last year about like how a lot of these cloud hyperscalers are looking to turn back on nuclear power plants just because they can't get enough electricity to power their data centers because they're growing these AI workloads so quickly. And if you kind of pivot that now to, if I can offload some of that processing to my PC and be much more effective in terms of energy consumption, that's a win for the environment. It's a win for the company because my TCO, my cost to deliver a lot of these solutions drops down significantly because I'm a lot more power efficient at the edge than if I have to rely on the cloud to do that.
Yeah, it's really amazing how rapidly this is changing, but the tools are coming forward, and that's something we want to help with, developing these tools to help our customers make the best decisions. And that sort of gets us into kind of governance and approach. And so again, you're out with a lot of customers. What do you think our customers should be focusing on in terms of prioritization, governance? How do they decide what they should do or what's the most important in what they're trying to achieve with AI?
Yeah, so I would say I view AI as it's going to become a competitive advantage for those companies that are in a particular industry that are making that investment. And if it's a way that I can make my employees more precise and more productive and more efficient in how they do their daily tasks, then it's a win for me. And so then the question is do I invest all of my AI strategy in the cloud, in your data centers, or do I look to find the right balance so that I can actually be more resilient in terms of how quickly I can deliver those workloads? And I would just say, if for folks in the audience, if you're not engaged with like your data scientists or the folks that are exploring those AI strategies, most of those people, when we talk to them, they're only anchored on cloud, data center. They're not thinking about the fact that, wow, a lot of these workloads can run on the edge. And for us at Qualcomm, when you think about all the different areas we're in, automotive is a great example of where we're delivering AI workloads to the automobile, because things like assisted driving, telemetry, all those things, the more processing that can occur in the device, in the automobile, it's going to lead to a better experience than if I'm having to wait for the latency to send that data up to the cloud and then process back down again. And we're bringing that same knowledge now to the PC and other areas.
That's great. I guess with that, right, you think about you bring up this point about the data scientists are focused in the cloud, and most of the people here are focused on end user. And I think we see that a lot of times, right? Companies get siloed. And so we would ask, go talk to your data scientists, make sure they understand. I don't know if you've seen any really compelling sort of approaches that companies have taken to make sure they get that, to have a more holistic view, because I think that's a problem that happens all the time, right?
Yeah.
Somebody comes up with an idea, and I think those of us who have been in the end user, how many times have you heard, hey, we want to roll out a new app tomorrow? It's the first you've heard of it, right? That happens occasionally. So have you seen things where people have done a better job of creating governance councils or integrated models for that?
Yeah, like I think it becomes this multi-headed conversation, because you end up needing also your CISO team involved as well.
Yeah.
Because it's all about, where's the data going? Is it protected? Is it leaving my domain, my network, and so forth? So yeah, like we do a lot to help bring together those different audiences. And I would also say, like, what's organically happening already is that on the security side, a lot of these ISVs are starting to see value in, how do I retrofit and how do I enhance my solution to run on an NPU, to basically leverage these local language models. And when you think about what a lot of these security agents are doing is they're typically running in the background, they're consuming a lot more of your system resources, and they're trying to detect bad things, right? And then react and fix them. So having those resources be pivoted to an engine, an NPU that is, consuming a lot less power, is going to allow the CISOs to perhaps be more effective in delivering more security agents and more experiences where they're right now handcuffed. And we see a lot of that friction right now between the CISO teams and desktop compute teams, because they want to do more on the CISO side. Desktop is struggling because there's only so many resources, only so much headroom you have on the device. So.
Yeah, I like that, right? Because user experiences, I come from the desktop side, and I'm user experience first, and you're right, you're always fighting with the security tools. And I think, staying in the security tool for a minute, we saw some examples yesterday from McAfee. We've seen some examples from CrowdStrike and some others about some of the things they're doing to specifically leverage these new capabilities. Do you think, how long do you think it's going to be until one of these companies comes out and says this capability only exists on an NPU-enabled device, and now you've got tough decisions in your enterprise? Did I upgrade enough? Is there a world where that's going to happen?
It's tough, right? Because they don't want to necessarily isolate their existing customers that aren't yet ready to upgrade. But I do think in a lot of ways, the economies will pay for itself, where if I can, provide a much better experience, because by upgrading my PC infrastructure to leverage these new capabilities from, say, a CrowdStrike, it's a win-win for everyone. So I am seeing more enterprises look towards leasing models, towards more frequent refreshes, because they understand that we're at a pivotal point right now where a lot of this revolutionary stuff is happening at the PC layer. I would just say the more resilient you can be in terms of being on, the newest or the N-1 version of Windows is probably going to become important, because Microsoft's continuing to push the envelope. Today, it's 40 tops for Copilot Plus PC. Next version of Windows, it'll probably be, at least 50% more than that, as they're trying to put more of those experiences into the operating system. So,
well, and with that, where do you see, Snapdragon? You've hit the ground running. Where do you see this going over the next 1 to 3 years? What do you see happening and changing with your products or in the market space?
Yeah, I'll be the first to admit, when you introduce a new architecture, like Windows on ARM is a different architecture than Windows x86. There is sort of a plateau, an initial lift to get to being able to properly ingest the operating system, ingest some applications that need different applications that are specific to ARM. But I do think that once you get to that next plateau, once you do that initial heavy lift work, this is the future. Microsoft is able to do a lot more with this reduced instruction set of the OS than they can on a traditional x86. So I do think you're going to see a lot more options. There's no surprise. There's another vendor right now that had said they're moving to ARM and more in the the GPU side. So I think you're going to see tide rises all boats. So if you start to dip your toe in the water now with a Snapdragon architecture, I think the long-term play is going to be Windows on ARM is going to become more and more prevalent because it's going to be a lot more capable of meeting your needs from a AI perspective, per watt perspective, thermal perspective. So
that's great. Well, we're just about out of time here. So I think the last question I want to ask you, speaking to the folks in the room, what would you suggest specific steps for them to take to look at ARM or to look at embracing more with AI PCs?
Yeah, so I would say, SHI is a great partner. The hardest step here is going to be more the people and the process part of it. So the applications are supported. The silicon performs incredibly well. It's more that heavy lift of introducing this next architecture. So, my team provides technical support, both pre and post sales, but we really rely on partners like SHI to help with that implementation phase to get you to that next layer of the plateau.
Well, good, Greg. I really appreciate your time
today.
No,
thank you.
It's always good talking to you. We're here to help, right? So I think they'll flip the slide. We'll have the ubiquitous QR code on screen here. You can scan that. We're here to help you understand the right fit of these platforms for you. We've got the Next Gen Lab to help out. So reach out to your sales reps, reach out to me, reach out to Craig. We'd like to all help you on the journey. So thank you, Craig. Thank you, everyone, for your time.
Thanks.